All right, 3.4. All we're doing is substituting all these values in. So f of x is just a fancy way of saying, hey, y equals negative 2 squared minus negative 2 minus 4. So that's all you're doing when you plug those in. And so you just watch out for your negatives. So this is minus positive 4 plus 2 minus 4. So minus 4 plus 2 is negative 2, minus 4 is negative 6. So what you found was when x is negative 2, y is negative 6. So these are your x values that are going in, and f of x is your y value. Okay, so we plug 0 in, we're going to get the same thing. So 0, 0, minus 4 would be negative 4. So when x is 0, we get negative 4. And if you plug in 4, you start all over, and you do y equals negative 4, negative, and then 4 squared, minus 4, minus 4. So y equals negative 16 minus 8. That's negative 8, and that would be negative 24. So that answer would be for negative 24. All right, so number 3, do the same thing. So y equals the square root of 3 minus 2 plus 3 times 3. And that is the square root of 1 plus 9. Square root of 1 is 1. 1 plus 9 is 10. So we get 3, 10. Next, 6. Y equals the square root of 6 minus 2 plus 3 times 6. And that's the square root of 4 plus 18, which is 2 plus 18, which is 20. So when x is 6, y is 20. And the last one, 11. Square root of 11 minus 2 plus 3 times 11. And that's the square root of 9 plus 33, which is 3 plus 33, or 36. So when x is 11, y is 36. And so there are all your answers: negative 6, negative 4, negative 24, 10, 20, and 36. So just to show you, negative 6, negative 4, negative 24, 10, 20, and 36. All right, number 5. Okay, so you're just plugging in all these things for all these letters. So letter A. We're going to plug in A for the x value. So f of A equals 5 times A minus 2. So 5A minus 2 is that answer. Okay, and then for B, we're putting in negative A. So 5 times negative A minus 2 is negative 5A minus 2. And we'll just put boxes around these to check quickly. And C, the opposite of f of A. Well, we already have f of A, so the opposite of what we have up there in part A, the opposite of that is going to be 5A plus 2. And now we go to D. Let's put D down here. A plus H. So y equals 5 times, we're substituting A plus H in, minus 2. So that's 5A plus 5H minus 2. Can't do anything else with it. And now let's do E. E is going to be f of A plus f of H. Well, we have f of A already. That's part A. So that's 5A minus 2. And then we are adding f of H. So let's plug H in. So H would be 5H minus 2. So we have 5A plus 5H. And minus 2 plus a negative 2 is minus 4. And the last one, we need f of A plus H, which we have in D. And so that's the first part. And then f of A we have in part A, and then divided by H. So all we have to do is put those answers. So part D's answer was 5A plus 5H minus 2. And then we have a minus f of A, which is part A. So minus the whole thing, 5A minus 2. Be careful, it's a group, all over H. So we distribute that through. We get 5A plus 5H minus 2 minus 5A plus 2 all over H. So these 2's here will cancel each other out, negative and a positive. we have a 5a and a negative 5a. That cancels out. So we are left with our answer of 5h over h, and the h is reduced out, and the answer should be 5. And there are all your answers, so they should match, and I think they do. And let's go on to number 7. Okay, so now we're going to do the exact same thing. So part A is negative a squared plus 3. So that's just negative a squared plus 3. Part B, f of negative a, so we're going to put a negative a in and square it, which doesn't mean anything. So you square a negative, it's positive, and you're still left with a negative a squared plus 3. And then C is a negative f of a. Again, take f of a, and what you had on the first one, f of a, you have a negative a squared plus 3. So we're going to take the opposite of that, which is positive a squared minus 3. And then part D is f of a plus h. So we have negative a plus h squared plus 3. So that's a binomial squared. So you're going to get the a plus h times the a plus h. So you get a negative a squared plus 2ah plus h squared plus 3. And that is negative a squared minus 2ah minus h squared plus 3. So these are the answers we're looking at. We're going to use these. So part E is f of a plus f of h. F of a was in part A, so that's negative a squared plus 3. And f of h we don't have yet, so put h in, that's negative h squared plus 3. So negative a squared minus h squared plus 6. And now f. F of a plus h was part D, so that's negative a squared minus 2ah minus h squared plus 3. And minus f of a. Again, f of a. You could do part A, or you could do C, which is the opposite of f of a, which is really what it's saying. So we can go ahead and put C in here, which was the a squared minus 3. Now I don't have to distribute the minus sign because that's minus f of a already. So if you notice down here, minus f of a. Otherwise, you have to take f of a, and then you distribute the minus sign, and you'll get the a squared plus a squared minus 3. Okay, so again, the negative a squared plus 3 is going to be positive a squared minus 3, which is what we have right there. Okay, so either way, just go ahead and put it in there, and then we have that all over h. And you simplify. You have an negative a squared, positive a squared. Those are gone. Looks like we have a negative h squared minus 2ah, and the plus 3 and minus 3 cancel out all over h. And you notice they all have h's in them. So if we factor out a negative h, we'll get h minus 2a plus 2a on the inside all over h. The h's reduce, and we have a negative h plus 2a in parentheses, or you can distribute the minus sign. Okay, so there are those answers. You can check them out. And let's move past this. We don't need to do another one. Okay, so let's just go to number 11. We're still just substituting things in. So g of 1 over a is just plugging or substituting 1 over a in the x positions. All right, so this is going to be 4 times 1 over a squared, or 4 over a squared. And then we do g of, or 1 over g of a. Okay, so g of a is going to be 1 over 4a squared. You're just plugging in the a in the x squared position. So it's 1 over that. That's the answer. And then we have, let's see, a, b, and c is g of the square root of a. So that's going to be 4 times the square root of a squared, which is just 4a. And d is the square root of g of a. Okay? So again, g of a is going to be 4a squared. And we're taking the square root of g of a, so that's going to be 2a. And there are your answers for a squared, 1 over 4a squared, and 4a and 2a. So let's have you try 13. Okay, so now we're going to do a little more complex problem here. We're going to put 1 over a in for every x value. All right, so this is part A. 2 times 1 over a, and 1 over a squared plus 1. So this becomes 2 over a in the numerator, and 1 over a squared plus 1. So let's do the denominator here. 1 over a squared, and 1 is the same thing as a squared over a squared. So again, let's simplify. We have 1 plus a squared all over a squared. You take the top, 2 over a, times the reciprocal of the bottom. And we get 2a squared all over a plus a cubed. So now we need to simplify. And we get 2a squared, a plus a cubed. Let's take out an a out of the bottom and get 1 plus a squared. So this 1a will reduce with one of those, leaving just 1 on the top. So we get 2a all over 1 plus a squared. Okay, now we'll go ahead and kind of erase most of the stuff and do part B. All right, so part B, 1 over g of a. All right, so 1 over, and we're going to plug a into this, and we get 2 times a, and a squared plus 1. So again, the top times the reciprocal of the bottom, and we just get a squared plus 1 all over 2a. And we can do C, got enough room here. So g of the square root of a, so 2 times the square root of a, all over the square root of a squared plus 1. So that gives us 2a, 2 square root of a, all over a plus 1. So there's B and C. So now let's do D. All right, so part D is the square root of g of a. So the square root, and now let's plug a in. 2 times a and a squared plus 1. And you can't have a radical in your denominator, so we have the square root of 2a, square root of a squared plus 1. So we're going to do the square root of a squared plus 1, square root of a squared plus 1. And we get the square root of 2a times a squared plus 1 all over a squared plus 1. And we distribute inside. That's 2a cubed plus 2a all over a squared plus 1. And that's our final answer. Let's move on. Okay, so explaining why a graph is or is not a function. If you have more than one x value for a y value, it's not a function. Or the vertical line test. We draw these vertical lines, it only hits the lines once. As opposed to number 16, this x value of 1 hits at 1, 2, 3 places. So like at 1, 4, 1, 0, and 1, negative, 1, 2, 3, 4, 5. So see, there's duplicate x values. You have more than one x value. One x value for multiple y values. So it's a weird way to think about it, but it's just the vertical line test. You're looking for multiple x values. Okay. 17, determine the domain, meaning what are the x values that work? So here's the easy way to do this. Just bring everything up to the x line and shade it in. This will come down, this will come down, and that's a colored in dot. So that's shaded there, so we can just kind of put that in. And then from 2 on to 3, but that's going to be an open dot as you bring everything down and everything back up. So what is our domain? Our domain would be all the x values such that, that's how you say it, how you write it, where x is, let's do intervals here, -3 to +1, and this is brackets, union with 2 with a bracket to -1 and a parentheses. So that's what's shaded there. That's domain. If you put everything down and up to the x-axis. All right, now the range, so let's go ahead and erase all of that. Hello. Not sure why that's doing that. All right, so let's do the range. The range is the same way. It ranges the y value. So all the y values such that if we move everything over and shade it, this is a colored in dot, that's a colored in dot, which is already shaded. All of this gets colored in, and this goes over to here. It's an open dot, and everything underneath it. So really, the whole thing from, was it 1, 2, 3? From -3, we always do our smaller numbers first, and that's a bracket, up to +1, 2, 3, and that's a parentheses. So that would be your range. So moving everything over to your y-axis is your range. All right. 19. For the graph of the function, f sketched in the figure, determine all of these things. All right, now listen up. This is important. You're going to have to do all of these things and understand all of these things as you're graphing as well. So on A, so part A, the domain, if we put everything up on the x-axis, would start at -1. So your domain is x such that it's a closed dot at -1. I'm sorry, -3. -3 is where that's at. And it's going to be shaded. There's no holes. So you're always looking for holes. All the way over to 4. And that'll be a bracket. So that is going to be your domain. Now, I think in the back of the book, it probably has less than or equal to x, less than or equal to 4. Either way. Now, B is the range. So your range values is y such that, whereas if we put everything in to the y-axis, so move everything over, there are no holes here, and it goes all the way up to 2, so it goes from -2 to 2. So again, and those are closed, so we're going to use brackets, or again, you would just say it like this, which is probably the proper way of doing this one, unless there are holes. If you have multiple things, then you want to probably use intervals. All right, now let's take a look at C. What is f of 1? So when x equals 1, what do we get? So look at where x equals 1. So I'll use a blue line here. Here's where x equals 1. X equals 1 is a vertical line going through the x-axis at 1. So when x equals 1, where are we on that line? Right here. So here's your line. Where are we on that line? Right there at 0, 1, 0. So f of 1 equals 0. So that's what you would put here. F of 1 equals 0. All right, now part D, I'm going to erase some of this stuff. I want this. Okay, D is all the x values such that f of x equals 1. So what that's saying is when y is equal to 1. Here, it's inside the parentheses where that means x, f of x, when x is 1. So I was talking about right here, when f of x, x being 1, okay? Over here, f of x, the whole thing, which is y equals 1. So be very careful when you look at both of those. This one is talking about when the x value is something. This one's talking about when y equals 1. All right? So if y equals 1, So now we draw a line where y equals 1, goes through the y-axis at 1. What do we get for x? Well, there's 3 values. So when y equals 1, x is -1, 1/2, and 2. Okay, now let's go to E, where y is greater than 1. So all the values not equal to, there's no equal sign there, so this would technically be a dotted line here. What do we have for everything above that yellow line? So again, if you put, it wants to know the y values, or the x values where it falls above it. All right, so since it's not equal, this is going to be an open dot, an open dot, and an open dot. And this is really the part that it's asking about. So what are the x values? That's what it wants. When y is greater than 1, find all the x values. All right, so since it's a shaded region, we're going to use interval notation. So from -1 to +1, and those are going to be parentheses, from 2, make sure you use the right numbers, all the way to 4, and 4 is included. Those are x values above the yellow line that are used. We need to make sure we understand all of this stuff. Okay, let's go on. Find the domain of f. All right, so first of all, it's pretty simple, but I'll draw a couple graphs just to make sure we understand. So on here, it's underneath, so it's going to shift your parent function 7 units to the left. 1, 2, 3, 4, 5, 6, 7. Okay? And the 2 is going to shrink it by 1/2. So it's still going to look like this. It's just everything's, closer and closer together. So the question is, when is this equal to 0? All right, when f of x or y, when y is 0, that's the x-axis, when y is 0, what makes the right side go to 0? That's what it's asking. All right, so if we square both sides, subtract 7, and divide off the 2, that's -3.5. 3 and 1/2, not 3/2. -3 and 1/2. Okay? Again, let's look at what it is. I put it at -7. So why is it at -3.5? Because of the shrinking of the 2. We shrank it horizontally by half. So if it was at -7, shrink that by a half back to the origin, it goes to -3.5. Or just plot the points, okay? Or do what we just did here. So visually, it doesn't say to graph it. Visually, this is what it looks like. Now, again, we're asking for domain, the x values such that. All right, the domain is, if we put everything down to the x-axis, what is shaded? It goes from -3 and 1/2, including 3 and 1/2, all the way to positive infinity. That would be your answer. Or you say x is greater than or equal to -3 and 1/2. All right, that's how you do it. Let's keep practicing. Let's move on. Let's erase this. Okay, let's go with 23. So again, this is going to be, it's a square root, so we know it's going to be drawn like that. So the question is, and you notice that there's a negative on the x squared inside. So let's graph a couple things here for us to understand what's going on. Okay, if you're always unsure, plot some points. So if x is negative, it's going to make it positive no matter what you put in. So if x is -4, -4 squared is 16, 16 minus 16 is 0. So 1, 2, 3, 4. If x is +4, it's going to go back to 0. Now watch what happens here. If x is -5, that's 16 minus +25, which gives you a negative. So it's not possible. You can't take the square root of a negative. So it's not going past -4, or it's not going to the right of positive 4 either. Okay, so let's put in negative 3. Negative 3 squared is 9. 16 minus 9 is 7. The square root of 7. How about negative 2? Negative 2 squared is 4. 16 minus 4 is 12. That's the square root of 12. And how about negative 1? Negative 1 would be 1. 16 minus 1 is 15. That's the square root of 15. All right, so notice they're increasing all the way up to when x is 0. If x is 0, 16 minus 0 is 0. Or 16 minus 0 is 16. Square root of 16 is 4. So as we leave negative 4, we're increasing all the way up to positive 4. Okay? And the same goes for this. So this is what the graph of this looks like. So you can use your graphing calculator and take a look at this. What's the domain going to be? Again, crush it down. And this is what's shaded. That's your domain. So your domain is the x values such that x is between negative 4 and positive 4. Okay, 25. All right, so you can put this in your calculator and graph it, and then just give me the domain. But I'm trying to get you to realize you definitely need to start paying attention to specific things. Okay, so if we look at number 25, just look at your denominator. X cubed minus 9x. This is what x can't be. You can't have 0 in your denominator. So let's just set it equal to 0 and solve. So we factor out an x, we get x squared minus 9. And that's the difference of squares, which is x minus 3, x plus 3. So x can't be 0. It can't be 3 and negative 3. So it can be everything else. So you could say x can't be these things, and that'd be good. All right, so let's erase this and do number 27. All right, let's do number 27. And again, the only reason we need to look at the top is what will make that be something bad, something that can't happen. So on 25, x could be anything in the top, and it would work. But in 27, you have a square root, an even root. So anytime you have an even root, the inside has to be greater than or equal to 0. It can be equal to 0, but it has to be bigger than 0 as well. Okay, so you have 2x minus 5. So what you do is you set 2x minus 5 to be positive or equal to 0. And we solve it. Add 5, divide off the 2. So x has to be greater than or equal to 5 halves. All right, and it's also equal, okay? But it can't be less than 2.5. All right, so now on a graph, anything that is over on the left side in the negatives, less than 2.5, anything less than 2.5 does not work just because of the radical in your numerator there. All right, in the bottom, we have x squared minus 5x plus 4. Okay, so now we go ahead and factor it. X minus 4, x minus 1, that gives you negative 5. Negative 4 times negative 1 gives you positive 4. All right, so in the denominator, we can't have it equal to 0. So what values of x make it 0? 4 and positive 1. So at 4, so here we have 2.5 is right here. And 1 is back here. So we know x can't be 1 because that's less than the 2.5 in the numerator. So that one doesn't even matter. But x can't be 4, which is right here. So that has to be an open dot. At 2.5, it works, so that's a closed dot. Everything greater than 2.5 works, except for 4. So visually, that's what you're looking at. So what's our answer? The domain is x such that x is greater than or equal to 5 halves except 4. You could do 5 halves to 4, including 5 halves, unioned with 4 to positive infinity. That's the same thing. All right, let's go to 29 here. And there's the answer, 29. So again, on the top here, x can be anything If it's 4, that just makes the whole thing 0, and that's possible. You can have 0 as an answer. So the numerator doesn't matter in this respect. So now we're only worried about what's in your denominator. So it's the square root. It's an even root. So again, it has to be greater than or equal to 0. And it's x minus 2. So we know x can't be 2. That'll make the denominator 0. So x can't be 2. And if we solve x minus 2 is greater than or equal to 0, we add 2, we get x has to be greater than or equal to 2. So you can't have 0 in your denominator, so we just said it can't be 2, so we need to remove the equal sign, and your domain therefore becomes x such that x is greater than 2, and that will work. All right, so we'll start making sure everything's in interval notation. The book isn't quite consistent yet, but let's just use that from here on out. And we'll look at 31. So on 31, let's go ahead and get rid of this stuff. 31, we have no denominators, except you have 2 radicals. So because you have an even root, each of these have to be greater than or equal to 0. 3 minus x has to be greater than or equal to 0 as well. So you solve these. X has to be greater than or equal to negative 3. So we subtract 3. Okay, but don't forget the minus sign. So divide off a negative 1, which changes the direction of your inequality. And a negative 3 over negative 1 is positive 3. Okay, so x is greater than or equal to negative 3. So on a number line, 1, 2, 3, greater than or equal to negative 3, and less than or equal to 3. So equal and shaded that way. So our answer should be between negative 3 and 3, including both of those. All right, moving on. 33, find the domain D. So there's 2 parts here. We have A and B. So part A, find the domain and the range. So again, domain is if you shade everything on the x-axis. So drop that circle down there, and this one's colored in, and everything else is shaded between. And squish this down, that's an open dot. Squish this down, closed, and that's shaded in between. That's up there, put that up there, and shade everything in between there. All right, so what do we have? Our domain would be that shaded region. So it'd be negative 4, including negative 4, all the way to 1, 2, 3, 4, 5. I'm sorry, negative 5. Back to negative 3. All right, and then union that with negative 1. So there's a lot of coordinates sitting here. Make sure you're using the x value. So that's negative 1, not including negative 1, all the way to positive 1, including positive 1. Union with the next set. So the next set here is, that's 1, 2. Make sure that's 2. Choose the right one. Don't say it's 3. 2, 3, 4. So 2 to 4. So 2, not including 2, all the way to 4, but including 4. All right, so make sure you count these. So you have 1, 2, 3, 4, 5. Negative 5 to negative 3. 2, 1, negative 1 to positive 1. And 2 to 4. That's what's tricky about this. Now that's the domain. Now we got to do the range. So I'm going to erase all that. And you're going to shade everything to the y-axis. That's a closed dot. This is open, except behind it is closed. This is closed here. This line is closed. A line is closed, okay? So that's going to cover up that open dot. So everything gets pushed this way. And there. So for the left picture, that's where that's at, which covers everything in this picture, except for this part here, all the way to 4, and everything underneath it. 1, 2, 3, 4. And then this bottom one here, this is only at 1, 2, 3, negative 3. So what's shaded? We always start with our, this is domain and range, starts with the smallest number, which would be negative 3. Okay. And then it starts up again at -1. So -3 is all by itself. And then -1 all the way up to 1, 2, 3, 4. And those are colored in, so those are brackets. So that would be your range. Now, part B. Let's go ahead and erase all of that. Find the intervals in which f is increasing. The function is increasing. And it's decreasing or is a constant. So where's the function increasing? And let's look at this picture right here. It's increasing. And we always give the x values. So the interval where x where the function increases on the x-axis. So on this one it would be from 1, 2, 3, 4, -4 to -3. Okay, to -3. It's not increasing at -4. That's the vertex. So you use parentheses when you're doing increasing and decreasing. And then increasing again in this picture from 3 to 4. And then let's do decreasing. So it's decreasing in this first section from -5 to -4. And in this picture, it's decreasing from 2, make sure you use the right coordinate, 2 to 3. And then constant, the function is constant from -1 to +1. Okay, so they use brackets when it was colored in, but that's really incorrect. So to stay consistent with your understanding that if it's colored in, it should be a bracket, that's in general what we're doing. At -5, -4 here, I should say, is the peak or the valley. It doesn't increase or decrease there. So it's decreasing from -4 to -5 to -4, and I'm talking about this part right here at the bottom. So -5 to -4. Now I can be convinced that a dot right there, it's decreasing at that point, but at the bottom it's level. It's not decreasing or increasing, so I would disagree with the bracket. But to stay consistent, I want to make sure you understand, if it's shaded in, then go ahead and put the bracket on it. That's not that big a deal. I'm more interested in the correct numbers you chose. All right, so to stay consistent, we'll go ahead and keep doing that. Let's move on. 35, sketch the graph of a function that is increasing from -infinity to -3, 2 to infinity, and is decreasing on -3 to 2. Okay, so let's draw a graph. You say, well, how do we know where everything's at? Well, I'll explain if you haven't figured this out. So from -infinity, which is way over here, to -3, 1, 2, 3, we are increasing. All right, so it's, and then it says it's also increasing from 2 to +infinity. So 1, 2, from 2 to +infinity, it's increasing. Now it's decreasing from -3 to 2. All right, so from -3 to 2, we're going down. We don't know if it's like this. Oops, all the way over to the 2 and up. We don't know if it's up here. It's the 3, -3, hits the 2, and then goes up. But typically what we're doing is you're going to go up through your x-axis, peak at -3, down through, and once you hit to 2, then you start increasing. You don't know exactly where these things are, but I'm going to teach you as we progress. Okay, so you just need to know that you're increasing until you get to -3. Let's use yellow here, -3. And at 2, you change directions again. That's what this is talking about. Where do you change directions? Okay, now, this is all very important for when we actually find out where these points are. Let's move on. Okay, 37. Sketch the graph of f. So we're going to sketch this first. Let's just draw it black. So our y-intercept's at 1, and from 1, our slope is negative 2 over positive 1. So down 2 and over 1, 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 up 2, left 1, up 2, left 1, up 2, left 1. And there we have a whole bunch of points that we can draw through. Now, part B, find the domain and range. Okay, so this is increasing going up and decreasing going down, but it is also going to the left and to the right forever. There are no holes here. There's nothing in the denominator or square roots. So if we were to push all of this down to the x-axis and up to the x-axis, everything would be colored in. It'd be shaded, okay? So the domain is all real numbers. Now what about the range? Well, the same type of thing. If we squish everything to the y-axis, there aren't any holes. So this answer would be all real numbers. And then part C, find the intervals on which f is increasing and decreasing or is constant. Well, it's only decreasing from negative infinity to positive infinity. So decreasing. Make sure you say that. And that's how you do that problem. Okay. 39, let's do the exact same thing again. Now we got to graph this. Let's rewrite this as y equals negative x squared plus 4. So a is negative, goes through the y-axis at 4. The exponent's a 2, so it's parabolic. So 1, 2, 3, 4. There is no b, so we know that this is our vertex. Otherwise, you have to find the vertex, negative b over 2a. Okay, and then a is negative, so it's going to open down. The question is it fat or skinny? Just plug in a number if you want to know. But the point is it's just going to keep going like this. All right, so the next question is find the domain of this. Again, if you have squish everything down to the x-axis and everything up to the x-axis, this continually goes to the left and continually goes to the right. There are no holes. So it's negative infinity to positive infinity. And the range, if you squish everything to the y-axis. Okay, these keep going forever down here, so it's shaded all the way from negative infinity. Negative infinity to what? To right here. Doesn't go past this. That's 4, and it's included. All right? So those are your domain and range. Now, the intervals of increasing and decreasing. So it increases from negative infinity all the way up to 0. Remember, you want the x values. Don't say it increases all the way to 4. Increasing and decreasing, domain and range, is all about the x values. The range, is about the y values. Everything else is the x values. So it's increasing from negative infinity to 0. It is decreasing from the x value 0 to positive infinity. And so let's stay consistent. Put brackets around the 0. Okay. We'll pause it, take a look at that answer. It's what we have. 41. Let's sketch the graph again. This is a square root function, so it's going to go up to the right, provided it's y equals, and it is, okay? So it's going to go up to the right. Our parent function starts at 0, 1, 1, and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. This is what our parent function looks like, okay? That's the y equals the square root of x. So the minus 1's on the inside, so it's a horizontal shift, opposite of what you think. So instead of going left, it's going to go to the right. And there's no other shifting. So this is what this looks like. So that's y equals square root of x minus 1. That's part A. Part B, domain. Squish everything to the x-axis. So you're going from 1 all the way to positive infinity. And again, keep it consistent. It's shaded at 1. So we'll color it in. The range, on the other hand, it starts on your y-axis at 0. And we shade everything here. This continually goes up, but it takes a long time to get there. But it does go up forever to infinity. So it starts at 0. Your range is your y-axis. It's included all the way up to positive infinity. Okay? So the intervals of increasing, it is only increasing. And the x values of where it's increasing is from 1 to positive infinity. It continually increases. It doesn't decrease. And it doesn't level off. All right. Good to go. 43. Sketch the graph of f. Find the domain. Okay, let's do it. So this is y equals negative 4. It's one letter, so that means it's linear, as long as it's not squared or something like that. So y equals negative 4. And that goes through the y-axis at negative 4. 1, 2, 3, 4. So let's do this in blue. There's our line. Find the domain and range. So your domain is all the x values. So squish everything up to the x-axis. That's negative infinity to positive infinity. Your range is negative 4. That's the only place it is, all right? Your intervals of increasing or decreasing, it's neither, so it's constant. Oh, those are all the problems. Good luck. Hopefully you learned a lot.